welcome to another video. In this video we are going to solve most frequent IDs problem from the Leetcode. In this problem we will be given a numbers array and a corresponding frequency array. We have to perform some operation at each index. Each index represents a particular step, and after performing that operation we have to determine what is the maximum frequency. Let's consider this first example to understand this problem statement better. We have this array nums and we have this frequency. Each index we have totally 4 elements. That means index will vary from 0 to 3. So what happens at step 0? At step 0 we have a number 2 and a frequency 3. That means for our collection we have to add number 2 3 times. Once we add 2 3 times, then what is the most frequent element? That is 2. The frequency is 3. So the most frequent is 2, but the count is 3. So the first answer, the answer that they are expecting at index 0 is 3. And now consider step 1. At step 1, at index 1, we have frequency 2 and a number 3. That means for our collection, we have to add the number 3 2 times. So we already had 2 3s after completion of step 0, and at step 1, we have to add 2 3s. So we are going to add 2 3s. And here, what is the most frequent element after the step 1? After step 1, we can see that 2 is still the most frequent element, and max frequency is still 3. So the answer for index 1 will also be 3. And now let's consider this is after step 1 and this was after step 0. And let's consider step 2. At index 2 we have a number 2, but the frequency is represented as -3. That means we have to remove the number 2 3 times from our collection. We have to remove the number 2 3 times from our collection. So what happens? After step 1 we had this collection and we are going to remove 2 3 times. Now our collection looks like this. After removing 2, what is the maximum frequency here? The most frequent element is 3, but the maximum frequency is 2. So for that corresponding index, answer becomes 2. This is what we need to understand in order to solve this problem. One way to solve this problem is we can put the corresponding number and the count in a dictionary, and then after performing each step, we can go through all the elements which are present in the dictionary and find out what is the maximum frequency. In this way, we have to go through the dictionary at each iteration. That's why the time complexity becomes O of n square. But if we have a data structure which can store the count in an increasing order, that will be very helpful. For that, we can use set data structure because set stores the elements in an increasing order in C++. Let's go through the coding part so that you can understand what I was talking about. How can we use set to get a better time complexity solution? The first thing that I'm going to do is I'm going to declare a map which is going to hold the count of each element. I'm going to call this as count. And another thing that I need is a set which is going to store, it is going to store a pair actually. The pair will have, the first element will be count and the second element will be corresponding number, and I'm going to call this as count set. And we need one answer array. So vector of, then it will be of type long. I'm going to call it as max frequencies. It will be of size frequency dot size, and let's initialize it to 0. it is not needed. Now let's go through all the queries and corresponding numbers. Int equals to 0, I less than nums.size I++. Now we will go through each step and try to add that to our collection. And the first thing that we are going to check here is if our count set already has this entry. So we are going to check count set dot find the thing that we are trying to find is the corresponding numbers count. So that will be nums of 5, but it will be stored in a dictionary, so it becomes the key. Count of nums of I and corresponding nums of I. If this is not equal to count set dot end, then we should remove it. We have to put this inside an if case. If it is already there, then before updating we have to remove it. So we are going to remove it from the count set dot arrays. We are going to pass the same thing. And once we remove it, the next thing that we are going to do is count of nums of I will be, we are going to add the corresponding frequency. It is going to decrement if it is negative. If the frequency of I is positive, it is going to increment the count of nums of I. Once we do this, then we are going to check if count of nums of I is not 0. If it is not 0, then we are going to insert it into our count set. Count set dot insert, we are going to insert the same thing. And now we have to determine what is the most frequent. Since the set stores the elements in an increasing order of the key that we are using is count of nums of I. So we have to get, first we are going to check if count set is empty. If count set dot empty, if it is not empty, then what we are going to do is, let's initialize all the values to 0 here. And now what we are going to do is we are going to assign the last element, since it is stored in an increasing order, max frequencies of I will be equal to count set dot, we are going to get the last pointer and the first in that pair, first element represents the count. And finally, after doing this for all the elements, we are going to return max frequencies because that is what is requested in the problem statement. Let's run this solution and check whether it passes the initial test cases. As you can see here, this is passing the initial test cases. Before submitting the solution, let's discuss about time complexity. Here we are using a set data structure which is going to store the elements in an increasing order. So for finding an element and inserting an element will take O of log n time. So we are doing this for all the elements. So the time complexity for this solution is O of n log n. We are going to do these operations for all the elements, so it will be O of n log n. And what is the space complexity? For space complexity, we are using one map and one set. So it can take O of n plus n. It usually becomes O of n. So the space complexity is O of n linear space complexity, and we have a time complexity of n log n. Let's submit the solution and check whether it passes all the test cases or not. Yes, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.